Okay, so what we're going to do here is we're going to look at a function that is not one-to-one. And so this function right here is f of x is equal to x minus 3 squared minus 2. And this is obviously not one-to-one. If we were to draw a horizontal line, you can see that it clearly intersects in two different places. So this function is not one-to-one. But what we can do is we can change the domain of the function to cause it to be something that is one-to-one. Okay? So what we're going to do here is we're going to see how to limit the domain of a function to make it one-to-one. And so just a quick review that this is a quadratic function, and you can see that we did a minus 3 horizontal shift. Okay, and so this x minus 3 implies a rightward shift by 3 units, and this minus 2 on the end implies a downward shift of 2 units. And so this point right here normally would be at the origin right here, and so it's gone this way. It's gone 3 units this way, and it's gone 2 units this way. And so now instead of being at the origin, it's at the point 3, negative 2. Okay? So what we're going to suggest here is this: what if we cut this graph vertically with a line so that it looks something like this? So if we do a vertical cut so that we cut off this side of the graph and all we have left is this side of the graph, would it then be a one-to-one function? Well, let's go over to Desmos and see what that would look like. Okay, so this purple line is where we're going to make the cut, okay? And the way I'm going to accomplish that is by changing the domain of the function x minus 3 squared minus 2. I'm going to add a domain restriction to where the graph goes from what appears to be negative infinity. I'm going to put in negative 100, but we won't be able to see it on the graph. And we're only going to go up to where this purple line is, which is at 2. Okay? And so you can see here that when we cut off the rest of the function, it now passes the horizontal line test. So if we were to put in a horizontal line anywhere, so for example at negative 0.5, or if we put it in at 1 or 2 or 3 or 4 or 5, you can see that it hits this graph in only one place. And so we have succeeded in identifying a piece of the graph that is that passes the horizontal line test. Okay, and so here's what we would say is that if we cut off a portion of this graph and limit the domain, so if we limit the domain to negative infinity up to 2, then it'll create a function that is now one-to-one. Now the other side of the function that's running from 2 up to infinity is not one-to-one. So if we were to look at the portion of the graph that goes from 2 up to infinity, you can see that it still is not one-to-one, because we can draw a horizontal line down here and it will cross over in 2 places. Okay? And so what we can do is basically just limit the domain of any function that is not one-to-one, and we can cause it to be one-to-one. But here's what we want to do is we actually want to make the domain optimal to where we can make both sides one-to-one. And what we would have to do in order to do that is, instead of cutting it at someplace back here, we want to cut it a little closer, like maybe here or here, a little bit closer until you can see where we're going. We're basically going to where we are cutting through the vertex of the graph, okay, which is at x equals 3. And so now when we cut at the vertex of x equals 3, now you can see that we have a graph that passes the horizontal line test on the right side, and it's passing the horizontal line test on the left side, okay? And the way that we accomplish this, like I said, is we make the cut, the vertical cut. So if we make the vertical cut right here where the vertex is, it will cause both sides of the graph separately to pass the horizontal line test. So now, if we limit the domain from negative infinity up to 3, and it would have to include 3, so we're going to put a bracket, or starting at 3 and going up to infinity, okay? And so here's what we're saying, is that this function f of x equals x cubed squared minus 2 on the domain from 3 up to infinity is 1 to 1. And so if we just give the domain limitation where x has to be greater than or equal to 3, or where x has to be less than or equal to 3, then we would have a quadratic function that is 1 to 1.